So let's talk about a new kind of invisibility cloak. But this one, it's not about hiding you from sight. Nope. It's designed to silence the invisible storm of electronic noise that our whole world is built on. Let's dive in.
You know the drill, right? You're on a plane, settling in, and the flight attendant asks everyone to switch their devices to airplane mode. We all do it, but have you ever really stopped to think about why? What's the big deal?
Well, it turns out that little switch is doing a huge job. It's preventing your phone from creating an invisible, chaotic storm of electronic signals. And when you're in a cockpit that's packed with super sensitive navigation and communication gear, that noise is a real potential risk.
And that brings us right to the heart of the problem that today's research is tackling. It's a thing called electromagnetic interference, or EMI. And believe me, in our hyper-connected world, it's a challenge that's just getting bigger and bigger.
So what is EMI? The easiest way to think about it is just electronic static. Every single gadget we own, your phone, your laptop, even your car, is constantly broadcasting electromagnetic waves. And when all those signals start crashing into each other, they cause interference. It can be anything from annoying static on your radio to, well, much more critical system failures.
For decades, the fix was pretty much a brute force approach. You just stick your sensitive electronics inside a big, heavy metal box. And yeah, it works. But it's a really clumsy solution for the modern world. You can't just wrap a satellite or a drone in a metal cage. We need something way smarter, way lighter, and built right into the device itself.
And this, right here, is where the breakthrough happens. Researchers at the University of Massachusetts Dartmouth are taking a totally new approach. Instead of building a box around the tech, they're building the protection directly into the material. They're designing a modern solution from the ground up. Okay, so the foundation for this new material is a polymer composite. The best way to picture it is like microscopic rebar, those are the strong glass fibers, suspended in a lightweight kind of concrete, which is the epoxy resin. This combo makes a material that's both incredibly strong and super light. But on its own, it's totally useless against electronic noise. It's missing the secret ingredients.
So, to turn this basic composite into a high-tech electronic shield, the researchers came up with this brilliant 3-ingredient recipe. And each part plays a totally unique role in defending against that invisible EMI storm.
The first ingredient is the smallest one, working at the nanoscale. We're talking about unbelievably tiny structures here. They're called carbon nanotubes.
These tiny nanotubes get mixed right into the epoxy, and what they do is form this microscopic, conductive spider's web all throughout the material. So when an electromagnetic wave hits it, this web is the very first line of defense. It catches that energy and starts to dissipate it.
But that little nanoweb can't do the whole job by itself. So for ingredient number 2, the researchers scaled things up just a bit, adding in some microscale carbon fibers.
Now think of these fibers as bridges. Their whole job is to connect the different layers of the composite together. They link all those separate little nanotube spiderwebs into one massive 3-dimensional electrical grid. This just dramatically boosts the material's power to handle electronic noise. All right, so now we've got this awesome electrical defense network. But for the third and final ingredient, the researchers added a really cool twist: magnetic nanoparticles. Specifically, a type of iron oxide.
This adds a whole new weapon to the arsenal. Now the material can mess with not just the electrical part of an energy wave, but the magnetic part too. These little particles help trap the wave's energy and convert it into tiny, totally harmless amounts of heat. It's the final piece of the puzzle that works together with that carbon network to make a seriously powerful shield.
So having a great recipe is one thing, but how do you actually cook it? I mean, the researchers had a huge challenge. How do you get millions of these tiny carbon fiber bridges to stand up and line up perfectly? Well, their solution is nothing short of a spark of genius.
No, seriously, just think about that for a second. You've basically got a pile of microscopic dust, and you need every single one of those fibers to stand up perfectly straight so it can connect the layers of your material. How is that even possible?
The answer, believe it or not, is static electricity. Using this process called electroflocking, they put the fibers on one conductive plate and the wet epoxy material on another plate right above it. Then they hit it with a high-voltage field. This makes the fibers literally jump up from the bottom plate and embed themselves perfectly straight into the epoxy. It is an unbelievably clever way to build that complex 3D network.
Okay, so we've got the advanced recipe and this genius manufacturing method, but the million-dollar question is still on the table. Did it actually work? Let's look at what the test showed.
Now, before we get to the numbers, there's a really important idea to understand. Some shielding materials work by reflection. They're like a mirror. They just bounce the electronic noise somewhere else, maybe causing problems for another device. But the best materials work by absorption. They're like a sponge, just soaking up that noise and making it disappear.
And the results were fantastic. The material hit a peak shielding effectiveness of 23 decibels. Now, decibels are a weird logarithmic scale, so what that really means is that it blocked over 99% of the incoming electronic noise. That is a huge, huge success.
But here's the most important part, the how. This thing was not a mirror. The tests showed that its shielding power was dominated by absorption. About 70% of its effectiveness came from acting like that sponge, soaking up the noise and neutralizing it. And that, my friends, is the gold standard for this kind of material.
So let's zoom out for a second. What does a material like this actually mean for the future of our technology? What's the big picture here?
Yeah, this quote from the researchers themselves really gets to the heart of what they achieved. The key wasn't just blocking the noise, it was absorbing it. By perfectly blending all those different ingredients, they created a system where the final result was way more powerful than any one part on its own.
This research really points to a big shift in how we think about the stuff we build things with. We're always pushing for materials to be stronger, lighter, more efficient, but this opens up a whole new frontier, materials that are electronically silent. Just imagine drones, satellites, and medical implants that aren't just high performance, but are also their own invisible shields. It leaves us with a pretty powerful question. What becomes possible when the very fabric of our technology learns how to be quiet?